Welcome to The Explainer. Today, we are breaking down a literally monumental release that is right now sending absolute shockwaves through the AI development community. Moonshot AI just dropped Kimi K3, and as we're going to see, this isn't just some standard incremental update. No, this is a massive leap forward that's fundamentally reshaping what we expect from open-source artificial intelligence.
Okay, let's just dive right into the sheer scale of this thing. 2.8 trillion parameters. Honestly, let that sink in for a second. This makes Kimi 3 the absolute largest open model ever released to the public. You know, when we talk about frontier-class intelligence, scale is kind of the entry ticket, right? Well, Moonshot AI hasn't just bought a ticket, they've effectively kicked the doors wide open with this staggering number.
And this puts things into perspective perfectly. It highlights just how massive a leap Moonshot has made compared to the historical trajectory of open frontier models. Kimi K3 just towers over everything. I mean, it's nearly double the size of previous heavyweights like DeepSeek V4 Pro, which remember sat at 1.6 trillion. This completely redefines the scale curve the open source community is currently playing on.
So here's exactly how we're going to unpack all of this today. First, we'll cover the largest open model. Then we'll go under the hood, check out the benchmarks and arena results, analyze performance versus cost, and wrap up with its impact on the AI frontier.
All right, Section 1, the largest open model setting a new standard for open weights. Let's get into it.
Let's look at what Moonshot AI actually delivered here, because K3 isn't just big for the sake of being big, it is incredibly feature-rich. Alongside those 2.8 trillion parameters, they've packed in a massive 1 million token context window. It also features native multimodal input, meaning it can natively process both text and images seamlessly, right out of the gates. But here's the real kicker, the detail everyone was waiting for. Moonshot officially plans to release the open weights for this absolute behemoth by July 27, 2026. That takes this from being a cool corporate asset to an unparalleled community resource.
Moving on to Section 2, Kimi K3 under the hood, demystifying the architectural magic. So managing and actually serving 2.8 trillion parameters requires some serious bleeding-edge innovation. You can't just scale up an old architecture and expect it to run without catching fire. And that brings us to their first major breakthrough, Kimi Delta Attention, or KDA. Now, handling 1 million tokens of context usually creates this massive computational bottleneck when decoding. Well, KDA fundamentally solves this. It allows the model to process information up to 6.3 times faster when working inside those huge context windows. Basically, it's the engine that makes a 1 million token claim actually practical to use in the real world.
And they paired KDA with another big innovation called attention residuals. Training a 2.8 trillion parameter model is, as you can imagine, mind-bogglingly expensive. But by throwing @10 res into the mix, Moonshot claims they hit roughly 25% higher training efficiency. The crazy part? It added less than a 2% increase to their computational cost. That is an absolutely incredible optimization win.
Now, what I find truly fascinating is how sparse the model actually is. Underneath the hood, K3 uses a latent mixture of experts architecture. Out of an astonishing 896 total experts, guess how many it activates at any given time? Just 16. That means its activation ratio is less than 2%. So while you have this gigantic 2.8 trillion parameter brain at your disposal, it's only firing a tiny, highly specialized fraction of those parameters to answer your specific prompt. That saves just massive amounts of compute during inference.
Okay, Section 3, benchmarks and arena results. The hype versus the reality.
Because, let's be honest, cool architecture means absolutely nothing without the execution to back it up. So independent testing gives us a much clearer picture. If we look at the Artificial Analysis Intelligence Index, which remember, aggregates 9 major evaluations, Kimi K3 lands a very strong score of 57. It completely bypasses the previous limits for open models and sits right near the top of the pack. But we do need to stay objective about exactly where it sits. As Artificial Analysis noted, its intelligence is right up there, comparable to Opus 4.8 and GPT 5.5. So yes, it's definitively a frontier model. However, it hasn't quite dethroned the absolute bleeding-edge proprietary models just yet. It's still sitting just behind Claude Fable 5 and GPT 5.6 Sol.
That said, when you dig into specific domains, the story gets even better. In blind human preference testing, like the front-end code arena, K3 actually surged to the #1 spot, 1,679 points. In this specific coding domain, it outright beat Fable 5. No small feat, right? It also snagged a number 9 rank in the general text arena, with top 10 placements in creative writing and instruction following. Oh, and it hit number 1 in Automation Bench AA. So in certain highly technical workflows, K3 isn't just competing, it's straight up winning.
Still, to keep the scales perfectly balanced, we have to talk about a couple of caveats analysts pointed out. First up, independent evaluators found that K3's hallucination rate actually worsened. It jumped to 51%, up from 39% in the older K2.6 model. Second, in coding benchmarks like Program Bench, some authors highlighted that K3's impressive scores relied on averaging the implementation percentage rather than strictly counting 100% fully working programs. And that metric can sometimes overstate a model's practical day-to-day coding usefulness. So it's brilliant for sure, but it's not immune to making mistakes.
Moving to Section 4, Performance versus Cost, the Wallet Reality Check. Let's pivot smoothly from high-minded benchmarks to practical economics, because frontier performance only matters if you or your business can actually afford to run the thing at scale. And this is exactly where Moonshot's sparse architecture really flexes its muscles. If we look at a blended cost, assuming 80% input tokens and 20% output tokens, Kimi K3 costs roughly $5.40 per 1 million tokens. Compare that to its direct competitors in intelligence. Claude Opus 4.8 comes in at $9, and GPT 5.5 is $10. Basically, Kimi K3 is giving you near Opus-level reasoning for barely more than half the price.
And that brilliant pricing translates directly into real-world workflows. Look at the average cost to complete a task on the Intelligence Index. Kimi K3 comes in at just 94 cents. It beats GPT 5.6 Sol's $1.04, and it completely undercuts Opus 4.8, which sits way up at $1.80 per task. This really grounds all that lofty 2.8 trillion parameter tech into an undeniable, very attractive business reality.
And finally, Section 5, Impact on the AI Frontier, the Community Verdict.
So taking all of this in, the unprecedented scale, the super smart sparse architecture, the top-tier benchmarks, and that aggressive pricing, what does this massive open release actually mean for the broader trajectory of AI? Well, the community consensus is overwhelmingly clear. This is a true historical milestone. People are already comparing it to earlier seismic shifts in open-source AI, calling it a DeepSeek moment. It proves undeniably that the open-source community isn't years behind anymore. They're operating mere weeks, maybe months behind the proprietary giants. Plus, the ecosystem is moving just as fast. Literally on day 0, the super popular open-source inference engine VLLM implemented support for K3's unique KDA architecture, which was contributed directly by Moonshot themselves. The baseline for what enterprise developers can now build on their own servers just shifted dramatically.
Which leaves us with this final kind of provocative thought to chew on. If a team can successfully engineer, optimize, and open source a highly competitive 2.8 trillion parameter model today, who's ultimately going to win the race to artificial general intelligence tomorrow? Is the future of the ultimate frontier going to be locked safely behind proprietary APIs, or does Kimi K3 prove that true AGI might just belong to the open source community? Thanks for joining me for this explainer. Keep learning, and I'll see you next time.